Let us now start discussing the next theorem, that is which is a converse to the theorem that we have done in part 1, chord properties. So the theorem that we did in part 1, let me say once again, the straight line drawn from the center of a circle to bisect a chord is perpendicular to it. So we have seen that it is true, we have proved it. Now we will be learning a theorem which is actually converse to the theorem that I have stated. Now what is converse? In your colloquial language you may say reverse, okay, but in mathematical terms we call it converse. So first let me state the theorem. There is no name for any theorem, the statement itself is its name, okay. So now for our convenience, as I told you, I will be naming it and numbering it as 2, but as I told you, the 2 is not fixed. So the statement goes like this. The perpendicular drawn to a chord from the center of a circle bisects the chord. Let me repeat the statement. The perpendicular drawn to a chord from the center of a circle bisects the chord. So can you see what I was telling to you about this converse or reverse? In the earlier part 1 we have seen that the straight line was drawn from the center of a circle to a chord, okay, but now it is said the perpendicular drawn from the center of a chord. There we proved that the straight line drawn from the center of a circle to a chord bisecting it is perpendicular. Now what is given to us? A circle with center O, a chord AB, the perpendicular drawn. So that means a perpendicular is dropped on the chord AB from the center of the circle. So the perpendicular drawn from the center of the circle to a chord. Okay, this perpendicular is drawn to a chord. Now we are proving that it will bisect the chord, or in other words we will prove that M is the midpoint of the chord AB. So are you getting my point? What is it converse? Here what we know, that the line drawn from the center O is perpendicular to the chord AB. That means already we know angle OMB is equal to 90 degree and also angle OMA is also 90 degree. That is given to us. Now we will prove that M is the midpoint of AB. That means OM bisects AB according to this theorem. Okay, so the perpendicular drawn from the center of a circle to a chord bisects the chord. That we will verify. Okay, so here what is already given to us, or what we already know, first thing given to us is a circle with center O. Okay, second thing AB, a chord. Okay, the other thing that we know, the perpendicular drawn to a chord. So OM is perpendicular to AB. This we proved in the earlier one, saying that OM is a line bisecting AB. Then we proved OM is perpendicular to AB. Now we know OM is perpendicular to AB and we will prove that OM also bisects AB. So let us again join OB and OA. So first of all what we are going to prove, what we want to verify, whether according to this theorem OM bisects the chord or not. Okay, according to this theorem the perpendicular drawn from the center of the circle 2A chord bisects the chord. So that we are verifying. So to prove AM is equal to BM, or what it means, M is midpoint of AB. That is what we are going to prove. Now for that, what is the construction that we did? Construction is join OA and OB. Okay. So now we will prove whether AM is equal to BM. Now for that, we will again consider the two triangles and we will try to prove that they are congruent. So consider triangles. Consider triangle OAM and triangle OBM. Okay. Now in triangle OAM and OBM, again we have OA is equal to OB, the radii of the same circle. So OA is equal to OB, radii of the same circle. Then we have OM is equal to OM, common for both the triangles. So OM is equal to OM. Also we know that each angle, that is OMA and OMB, is 90 degree because OM is perpendicular to AB given to us. So angle OMA is equal to angle OMB is equal to 90 degrees. Why? Because OM is perpendicular to chord AB. Right? So therefore one right angle, one hypotenuse and one side. Okay? OA is the hypotenuse, OM is the side, and this is a 90 degree. So they are congruent by RHS test. So therefore triangle OAM is congruent to triangle OBM by RHS test. Okay? So now they are congruent, means AM is equal to BM. Why? Corresponding sides of congruent triangles. So this implies AM is equal to BM. Why? Corresponding sides of congruent triangles. Okay? So implies M is the midpoint of AB. Agreed? So that implies OM is the bisector of AB, or OM bisects AB, isn't it? So what does the theorem say? We have proved. What does the theorem say? That the perpendicular drawn from the center of a circle to a chord bisects the chord. So that is what we have proved. So let me compare the theorem that we learnt in chord properties of part 1 and the theorem that we are learning in part 2. In part 1 we learnt that the straight line drawn from the center of a circle bisecting a chord is perpendicular to it. Here we are saying the perpendicular drawn from the center of a circle to a chord bisects the chord. So is the difference clear? That is why they are called converse to each other. Means you must be very careful which theorem to be used. What you know, according to the given conditions, you will have to use the theorem while applying it in solving other problems. Suppose you already know that this particular line, a given line in the question, is perpendicular and from the center it is drawn and is perpendicular to a chord, then you automatically can conclude that it also bisects the chord. Then by which theorem? By this. The statement should be written this as the reason. Okay. But if you are given that OM is the bisector of the chord AB, then you can conclude that OM is perpendicular to AB according to the theorem 1 of part 1 that you learnt. That is, again, so let me revise once again both the theorems. The statements are very, very important. The proof, whether it is asked or not asked, not very often asked, but the proof is for you to understand. Okay, so now you clearly know so that you can apply. Now this is true in any circle. These chord properties are true for any chord, for any circle of any measurement. So therefore, let us again revise the two theorems that we finished in part 1 and now in part 2. The part 1 theorem says that the straight line drawn, let me draw the diagram also simultaneously, the straight line drawn from the center of a circle to bisecting a chord is perpendicular to it. So here it is given that M is the midpoint and O is the center of the circle and OM is the line joining the center of the circle and the midpoint of the chord. Then we can conclude that OM is perpendicular to AB. You need not prove. You can take it from this theorem because it is proved, universally proved. In the second part we know that what does the second theorem says? That the perpendicular drawn from the center of a circle bisects to a chord bisects it. Means we know that OM is a perpendicular drawn from the center of the circle to a chord AB. Then you may conclude that OM will be perpendicular to AB. And then only thing is the reference is this statement. You have to write this statement as your reason. So you should be very clear which one to write, which one you are using. If it depends upon what data is given to you. If you are told OM is the line drawn from the center bisecting a chord, that is the given condition, then you will conclude that OM is perpendicular to AB from the theorem 1, that is the statement you have to write. Whereas if you know that a line OM is a perpendicular to AB, where O is the center of the circle and AB is a chord, then you can conclude saying that M will be the midpoint of AB and the reason will be this statement. In square brackets you must write. As we use in further subsequent parts, we will be solving sums using these theorems, then it will be more clear to you. But first of all, the theorem should be, meaning should be very much clear. I hope it is all clear to you children.